Today, let's discuss about the planets Jupiter and Saturn. Yesterday, we were studying about Earth, Mars, and the asteroid belt, right? We also studied about comets and where these comets come from. And today, we'll concentrate on Jupiter and Saturn. So, yes, from Jupiter onwards, the four planets Jupiter, Saturn,
So, Miss,
Uranus,
we are
and
going to
Neptune.
study about the Jovian planets today.
Yes, it is. So from Jupiter to Neptune, we call Jovian planets or the gas giants. And the Neptune and Uranus are sometimes also called icy giants. Yes, so Jupiter, it is the fifth planet from the Sun and the largest planet in the solar system. It's also called the Lord of Heaven. It's a gas giant with mass 1,000 that of the Sun. But this is an interesting fact that 2.5 times the mass of all the other planets in the solar system combined. We were talking about the planet Jupiter. Just this is the first slide. It is the fifth planet from the sun and also the largest planet in the solar system. We were studying about the size of Jupiter. That consider the mass of Jupiter compared to the sun. It's only 1,000 of sun, but look at the mass of sun when compared to the all other solar system objects. You take all the other seven planets and their moons and dwarf planets, asteroids, everything together. Then also it has to be multiplied with 2.5. That is 2.5 times bigger, massive is Jupiter. Jupiter was named after the Roman god who was a leader of all gods. Just like we have Devendra in Indian mythology as the god of gods, right? But in India, we call Jupiter Brihaspati, right? The guru of this gods. Yes. Now, in Roman mythology, Jupiter was the biggest and most powerful god. And because of these characteristics and size, the planet was given that same. So, how large is Jupiter compared to Earth? Jupiter has a diameter of about 88,695 miles, that is 1,42,800 kilometers, which is more than 11 times the diameter of Earth. So, if you line up 11 Earths, you'll get the diameter of Jupiter. And its volume is over 1,300 times the volume of Earth. So it means we could, fill 1,000 Earths inside the Jupiter. Why only 1,000 Earth? Because Earth is in spherical shape, right? So there will be gaps in between. That's why. So actually, the volume of Jupiter is 1,300 times the volume of Earth. Jupiter is so big that it weighs 2.5 times the weight of all other 8 planets put together. Look at this. The Earth could fit inside Jupiter over 1,000 times. Do you know who discovered the planet Jupiter? But there is no single person who is credited with the discovery of Jupiter because Jupiter is one of the 5 planets that can be seen in the night sky. We can see Mercury, Venus, Mars, Jupiter, and up to Saturn. Beyond Saturn, we cannot see these planets. So, in the ancient times when people were looking at the sky, they might have seen Jupiter already. But Galileo Galilei, he was the first one to observe Jupiter with a telescope. He found different things such as, its 4 moons called the Jovian moons, the red spot, the features, etc. Jupiter can be seen from planet Earth, so it is hard to tell who exactly saw it first. We will never know when Jupiter was discovered. Just we'll know time immemorial. Now about the structure of Jupiter. Jupiter is composed of primarily gaseous and liquid matter. It is the largest of 4 gas giants as well as the largest planet in the solar system with a diameter of 1,42,984 kilometers at its equator. The atmosphere of Jupiter contains 75% of hydrogen and 24% of helium by mass, with the remaining 1% of the mass consisting of other elements. But in the interior, there is a little change in the composition. It becomes denser and it may contain denser material such that the distribution is roughly 71 percentage of hydrogen, 24 percentage of helium, and 5 percentage of other elements by mass. The atmosphere of Jupiter, it contains trace amounts. Trace amounts means a small amount of methane, water vapor, ammonia, and silicon. Silicon based compounds means, silicon oxide also. Like there are different compounds in which silicon can be a base. And there are also traces of carbon, ethane, um, hydrogen, sulfide, neon, oxygen, phosphine, sulfur, etc. Now, this is the internal structure of Jupiter. Here in the center, there is a core, and here we do have a liquid metallic hydrogen and helium, then followed by liquid hydrogen and helium. So, what is this metallic hydrogen and helium? Which means if it's like if a thing is metal, consider iron. Iron is a metal, right? But if it is undergone heavy pressure, a huge amount of pressure and large temperature, it could be in liquid form. For example, mercury, it's a metal, but in liquid form in room temperature. So just like that, it's not solid, but still liquid metallic hydrogen and helium. And it's followed by liquid hydrogen and helium, and there is atmosphere. And here you can see one of the most uh, prominent feature on the surface of Jupiter, which is the great red spot. We will study about this red spot in the coming slides.
Ma'am, I did not get up the part about the liquid metallic hydrogen and helium.
Metals can be liquid sometimes. For example, mercury is a metal, but it's in liquid form in room temperature, right? Similarly, if it is undergone um, pressure and temperature, it can be metal. It can be liquid, metallic liquid. It will be metal, but don't consider that solid metal, but liquid metal.
So liquid metal is mixed with hydrogen and helium.
Yeah.
Okay.
It's not like that. So hydrogen, how we call something metal? Hydrogen, if it is, if you consider hydrogen, in which group hydrogen is presented? It's in the first group, right? Alkaline earth metal, but it shows like it's given separate. So what do you mean by metallic hydrogen? I'll tell you. Excuse me, ma'am. Yes. All these questions can be asked in the end of the session. Okay, if that is okay. Actually, this metallic hydrogen, it's a phase of hydrogen which it behaves like an electrical conductor. Metal is a conductor, right? Metals are, it can conduct electricity or whatever in that. So such metallic properties, if it is shown by hydrogen, we call it metallic hydrogen, and if it is in liquid form, we call it liquid metallic hydrogen. That simple it is. Moving to the next slide. Yeah, Jupiter's mass is 2.5 times. We already said that of all the other planets in the solar system combined, and this is so massive that its barycenter with the sun lies above the sun's surface, which means that even though we say that all the planets revolve around the sun, actually planets and the sun, they are revolving around a common center, that is their center of mass point, and that point is called barycenter. Since Jupiter is really big, its barycenter is in above the surface of sun. So actually sun is also moving a little bit as revolving. I mean, revolving around that single point, just like Jupiter is also revolving. Even in the case of Earth, also this is true. Earth and Sun, they are revolving around a common point, but that common point is within the surface of the Sun. Why? Because Sun is massive than that of Earth. But in the case of Jupiter, it lies above the sun's surface, some 1.068 solar radii from the sun center. And Jupiter's volume is that of about 1,321 Earths. Yet the planet is only 318 times as massive. So Jupiter's radius is about 1 by 10th of the radius of Sun, and its mass is 0.001 times of the mass of the Sun. So the density of the two bodies are similar. And now, whenever we see Jupiter, we see different stripes on it, right? What are these stripes? And also these stripes are of different colors. Some are darker and some are lighter. So the light colored bands are called zones, and these are regions where gas in Jupiter's atmosphere is raising upwards. So these zones are regions in the Jupiter's surface where the gas are coming up. Okay, and there are another band which is darker. It's called belt. And these are regions where the gas in Jupiter's atmosphere is sinking downwards. So these,
Ma'am,
yes,
I not understood the mass of Jupiter. Can you explain me again?
mass of Jupiter.
Yeah.
Okay, mass of Jupiter, we said that is 0.001 times the mass of the sun. Okay, that is 1,000th the mass of the sun. Okay, did you understand?
Oh yeah, thank you.
Yeah, fine. Yes, now we were talking about the zones, and there are two zones, two kinds of belts, two kinds of bands are there. One is zones and belts. They're continuously, there alternatively there are these bands, and the zones are lighter bands, and belts are darker bands. In lighter bands, the gas in Jupiter's atmosphere is rising upward, while in the other one, which is the darker band, the belts, these are the regions where gas in Jupiter's atmosphere is sinking downwards. It is continuous, not a permanent feature, it's continuously changing. Now, how strong is the gravity on Jupiter? The gravity on Jupiter is greater than the gravity on Earth because Jupiter is more massive. Now, although Jupiter is a great deal of larger in size, the surface gravity is just 2.4 times that of the surface gravity of Earth. Why is that? This is because Jupiter is mostly made of gases. If you weigh 100 kilograms on Earth, nobody is 100 kilograms. Say, yeah, if you weigh 100 kilograms, okay, you would weigh 214 kilograms in Jupiter, just like that. Now, the moons of Jupiter. Jupiter has, some years before it was, first it was found 10, then it had 20, 30, and now it is said that it has dozens and dozens of moons. It may have, now
It is
it
said
is
it has
92.
more. This it is just said that it has 100 plus moons.
Yeah, yes. And also in the future, more and more moons will be. So the number of moons are not important. In some point, it was
Like after 79, they discovered that it's 92 moons, and after that, like now they're saying
that is true. Now about the Galilean moons. So these are the four important moons of Jupiter. So it was Galileo Galilei who discovered the Jupiter's four largest moons in 1610 that we called the Galilean moons, and they were the first objects found to orbit a body that was neither Earth nor the Sun. And these four moons that mostly seen are Io, Europa, Callisto, and Ganymede. These are the four Galilean moons. It was Galileo Galilei who discovered it with his telescope, and they are Io, Europa, Callisto, and Ganymede.
this Ganymede is like the biggest moon in the whole solar system.
Exactly. Ganymede is the biggest moon in the whole solar system, and it is even bigger than that of Mercury, the planet. Now, this is the picture of Io. This is Europa. This is Callisto, and this is Ganymede. Now let's talk about the orbit and rotation of Jupiter. Jupiter is the only planet that has a center of mass within the Sun that lies outside the volume of the Sun. So by only 7% of the sun's radius. The average distance between Jupiter and the sun is 778 million kilometers, about 5.2 times the average distance from the Earth to the sun, or 5.2 astronomical unit. And it completes an orbit every 11.86 years.
Ma'am,
Yes.
for the exam, are we expected to learn all of these numbers by heart?
No, it is
Like,
not. No, only the important ones you should learn. It's hard to learn all these numbers. You don't no need to learn. Just you need to understand how much. Like for example, it's 5.2 astronomical unit from Earth to Sun to Jupiter, and one astronomical you should remember. So that's how if you get a question also you could answer. Not blindly, just don't mug up the numbers. Just make an idea of the distance of different planets and celestial objects within the solar system. Okay.
all right.
Yes, very good. And yeah, about the axial tilt of Jupiter. Jupiter is relatively having a small axial tilt, only 3.13. So what is the effect? The effect is, as a result, this planet does not experience significant seasonal changes, in contrast to the Earth and Mars, for example. Just like Venus and Mercury, their axis tilt is very less, so that this Mercury and Venus case I am talking. Um, since their axis tilt is almost zero, they won't be having any seasonal difference.
3.13
So Jupiter's rotation is the fastest of all the solar system's planet. Yeah, did we talked about that previous slide? Yeah, there is no specific seasonal changes in contrast to Earth and Mars. Yes, the Jupiter's rotation is the fastest of all the solar system's planet, completing a rotation on its axis in slightly less than 10 hours. This creates an equatorial bulge, just like we yesterday talked about Earth's bulge, right? And we named that particular shape oblate spheroid. And regarding Jupiter, Jupiter rotates very fast. It's having the fastest rotational velocity of all the planets. So in some 10 hours or so, it will rotate on its own axis a single time. Because of this fastest rotation, what happens? In the central part, in the equator part, there will be bulge. And this shape is called oblate spheroid. And it means that the diameter across the equator is longer than the diameter measured between the poles, which means, horizontally and vertically we are measuring the radius. The horizontal radius will be more than that of the vertical radius, which means center to the equator radius will be more than the center to polar radius. On Jupiter, the equatorial diameter is 9,275 kilometers, almost 10,000 kilometers, right? Longer than the diameter measured through the poles. Now, since Jupiter is a gas planet, it does not rotate as a solid sphere. When we were studying about Sun, we discussed about this. These gas giants, they actually are not rigid bodies which revolve in same speed. No, they are not. And so different belts in and these different bands in this or regions in this planet Jupiter is rotating in its own speed. In polar region, it will be more, and the central region, it will be less. This is also one of the reasons why its middle has been stretched out rather than round, it is short and flat. Yes. Now there comes the great question that what is this great red spot? So red spot, it's actually a huge long-lasting storm in the atmosphere of the southern hemisphere of Jupiter. It's an anticyclonic, which is high pressure storm. Just like, if some cyclones are there in Bay of Bengal, we study about that. Even, I forgot the name, Rimmel, yeah. The Rimmel cyclone was there in the Bay of Bengal Sea, Bay of Bengal during um, April, right? You remember? I don't know. So just like that, it is a storm permanently. I mean, almost long lasting. It's not permanent. It's actually reducing its size now. It's almost has Earth-like. It's bigger than that of Earth, but every year
Miss,
it shrinks.
it can fit about 3.5 Earths in its whole like area. And also, Miss, that storm was first spotted about 400 years ago.
Okay. It was Galileo Galilei who was spotted it for the first time. Yes, now, yeah. Its color is actually pink to orange. Now there is this thing. It was Robert Hooke, who was a popular scientist who discovered the great red spot of Jupiter in 1664. Yes, so now this is 2024, right? So exactly 400 years. Yes. So about the rings of Jupiter. We have heard about the rings of Saturn. Now, Jupiter also has rings. It has a system of rings known as the rings of Jupiter or the Jovian ring system. It was the third ring system to be discovered in the solar system. The first one was obviously Saturn. It has a huge ring system. And the second is Uranus. And after both these planets, it was found that even Jupiter has ring system. Actually, all these Jovian planets have a ring system. It was first observed in 1979 by the Voyager 1 spacecraft and thoroughly investigated in the 1990s by the Galileo. Saturn is not the only planet with rings. And in fact, Jupiter has a planetary ring system as well as moons that orbit the planet. The three segments of the ring system are halo, the bright main ring, and the gossamer ring. So in the this picture you can see the ring closer to the Jupiter. It's called the halo, and then there is this pink one. It's not pink in color. Just to mention that to distinguish it, we colored it pink, and it is the main ring. This is the main ring, and then it has two more rings, the gossamer ring. So unlike Saturn's ice ring, the rings of Jupiter appears to be composed of dust. And it appears that one of the rings of Jupiter was formed from material that was ejected from four satellites, Adrastea, Amalthea, Thebe, and Metis. Here in the picture you can see Thebe. Yeah, here see. It could have been the materials expelled from these four planets, satellites. Yes. So these are the flyby missions to the Jupiter. Some of the missions. The first spacecraft is Pioneer 10 in 1973, followed by Pioneer 11 for 1974. Then in the same decade, 1979, Voyager 1 was there, and then Voyager 2, the Ulysses mission, then Cassini-Huygens was originally sent to study Saturn. On the way, it got measurements, and then there is New Horizon mission. New Horizons was to the Pluto to study more about Pluto and the trans-Neptunian uh, objects. Then there are certain other missions called Galileo mission, which was sent in 1989. Then, yeah, Europa Clipper mission was there. Then, yeah, similarly, Juno mission was there in 2011 to study about Jupiter. All these are the, orbiter mission because we cannot land on these gas giants. There is no surface. So even though we are just impacting on this planet, it will just go beyond and beyond the gassy atmosphere and surface. Now there is this question: does Jupiter protect Earth from comets and asteroids? The answer is yes, it is protecting. Scientists believe that Jupiter's gravitational field is pushing comets and asteroids which are approaching the Earth away from the inner planets, diverting them to the outer planets and thus averting possible catastrophe. Basically, three types of objects, namely main belt asteroid, Kuiper belt comets, and Oort cloud comets, pose a threat to both Jupiter and the Earth. We know that there are yesterday we studied about asteroids, right? There are a lot of asteroids from different regions in solar system, like the asteroid belt or Oort cloud or Kuiper belt, just roaming around the solar system, and it could, Earth could come in contact with some of them, but most of these asteroids are being captured by Jupiter, and this is one of the reasons why we do not encounter with much of the asteroids. Okay, now, yeah, Kuiper belt comets are found to follow a path which is close to the orbit of Neptune, and long-term comets are known as Oort cloud comets. Yeah, yesterday we studied about that. So yes, this is the Jupiter slide. Hope you enjoy the slide. And next we will go to the Saturn slide. Hopefully the screen is uh, visible now. Yes, Saturn, the real Lord of the Rings. Saturn is the sixth planet from the Sun and second largest planet in the solar system. And Saturn has thin, seven flat and thin rings. Almost the thickness can be from some 10 meter, 20 meter to sometimes 1 kilometer. And yeah, about moons, not 82, more than 82 moons can be there, almost maybe more than 90 moons can be there for uh, Saturn. Now,
How can there be only 64 moons in the solar system and then Saturn have so many moons?
64 moons in the solar system. Who told that?
Miss, Jupiter itself has way more moons than 64.
Exactly. Maybe you're talking about large size moons. I'm not sure.
Wait, ma'am, I think didn't you share that in one of your previous slides? I think.
Sorry? Sorry?
Ma'am, I think you shared that back in one of the previous slides, like when we were doing about the solar system.
But these two planets, Saturn and Jupiter, they have a lot of satellites. Okay, a lot of them, more than 50 satellites are there for sure. Sometimes more than 90 satellites can be there. Anyway, This Saturn and the name, how the name came. Saturn is a Roman god of agriculture and harvest. And Saturn is said to be the father of Ceres, Jupiter, Pluto, and Neptune. He ruled during the golden age of man, and Saturn represents limits of control as it was thought to be the limit of the solar system. That's why it was named Saturn. There are some ancient observations about the Saturn. The farthest planet prehistoric astronomers knew, which is 9.5 times as far as from Earth, and it has a revolution period of 29.5 Earth days. It's mostly used in many of the mythology textbooks. And it was the planet that can be seen by Earth with naked eye. But the rings, yeah, rings we cannot see it. Just the planet we can see. Now the discovery of the planet, we told that it is not sure. We are not sure who discovered it. Many must have already been in ancient times. But who discovered the rings? It was Galileo Galilei who discovered the rings in 1610. But he believed that there are two moons on the either side. But later, Christian Huygens, he first coined the world ring, 1665. Now, where is Saturn located? It orbits the Sun at a distance of about 1.4 billion kilometers. And Saturn is about 9.5 times as far from the Sun as the Earth. And Saturn is almost twice as far from the Earth as is Jupiter, which is the fifth planet in the solar system. Which means that consider the distance between the Sun and Jupiter. That much distance, you take that as x. Then the same x distance is between Jupiter and Saturn. See, as we go beyond the Mars, the distance are more. For example, consider the distance from Sun to Mars. That is, say that is x. Then the same x is the distance between Mars and the Jupiter. In between, asteroid belt is there, but still. Similarly, from Sun to Jupiter, how much distance is there? That much distance is there from Jupiter to Saturn. Now, how big is Saturn? It is the second largest planet in the solar system. And there are 95 Earth masses combined. If we talk about the mass of the Saturn, and it's a gas giant, just like the other Jovian planets. And it has a diameter 10 times that of Earth. For Earth, diameter is approximately 12,000 kilometers, and for Saturn, it is 1,20,540 kilometers.
Huh?
Now here you can see a comparison picture between Earth and Sun. The planetary size comparison. Yes. So if Saturn is so much more massive than Earth, why is it said that Saturn could float in water? The mass is not just a point when we talk about floating, but something else is, which is mass by volume. That is called density. Saturn is the lightest planet, while Earth is the heaviest planet, right? In terms of density, Saturn has the lowest density of all the planets, while Earth has, higher density. It has only 2 by 3rd density of as water. So that's why Saturn would float in water. It's just a thought experiment, not just like Saturn is going to float in water. In this slide and coming slides, let's talk about what is Saturn made of. So primarily, Saturn is a ball of gas with no solid surface. 94% of hydrogen, 6% of helium, small amounts of methane and ammonia. And detailed analysis of Saturn gravitational field leads the astronomers to believe that the deepest interior of Saturn must consist of a molten rock core, which is same as that of Earth but more massive. So here you can see molecular hydrogen, then liquid metallic hydrogen beneath that, and there is core. It has a molten rock core. It is said to be of same size that of Earth. Yes, here you can see the first layer, which is molecular hydrogen, then metallic hydrogen, and then there is isotope. So mostly Saturn is made of hydrogen, helium, and methane. Yes. Now let's talk about the Saturn surface. Saturn is a giant ball of gas, believed to have no solid surface. Its inner core of iron and rocky materials, and outer core of ammonia, methane, and water. The liquid metallic hydrogen surrounds outer core. Oh, have you seen this kind of feature in the Saturn's polar region? It's called a hexagonal cloud. These kinds of clouds can be formed in these gas giants because the surface and atmosphere merge actually because there is no solid surface, right? So the surface along with the atmosphere they merge together, and the dense clouds cover Saturn. So all these clouds are being dense together, and they are actually covering the whole of Saturn. The differences in temperature and altitude causes patterns and different colors in the cloud top. This is an example of that. It is the difference in temperature along with the altitude that is causing patterns and colors in the cloud tops. Now, this is a comparison of different uh, depths at which different internal structure of Saturn. First one being, the core region. It is almost some 7,500 kilometers. It's metal and rock mostly, while the upper layer it is ice, rocky layer that is 16,000 kilometers thick, and up in the above the ice layer there is metallic hydrogen up to 30,500 kilometers. After that, up to 60,330 kilometers, there is molecular hydrogen. Now, let's talk about Saturn's orbit. Saturn's orbit is an elliptical one, and there is this property called eccentricity, which talks about how much elliptic an orbit is. And for example, the eccentricity of Saturn is 0.056, which means that aphelion reaches up to 10.1 astronomical unit, and while the perihelion it goes only up to 9 astronomical unit. Now it takes 29.46 Earth years for having one revolution around the sun. So one Saturn year is 29.46, that is 21.5 Earth years. Also, it has an axis tilt of 27 degrees. This axis tilt, Jupiter did not have much axis tilt, so there was no seasonal changes there. But here, for Saturn's case, there is. And about rotation, it is the second fastest of non-planets. Saturn rotates 10 hours 39 minutes. For simple rotation, it takes the 10 and a half hours. Mercury will take 28 days to one revolution. Venus 225, Earth 365 and 1 by 4. Mars 687. Jupiter 12 years. Saturn almost 30 years. Uranus 84 years. And Neptune 165 years. And this is the shape of Saturn. Just like Jupiter, it is Earth, etc. It also has an oblate spiral shape. It is because of this rapid rotation which is causing the planet to bulge. So this Saturn also has flattened poles and bulging equator. But no, there is this common, doubt that we talk about Saturn and Jupiter, right? Which means that the components, hydrogen, helium mainly, the components are found almost similar in both cases, but they look different. They both look different. Like in color, if you're talking, yes, they look in different color. Why is that? Saturn is a world of white and pastel yellow cloud layers, while Jupiter it has bright yellow, orange, and red in exotic swirls and storms. So why they are not similar?
Miss, the composition of the clouds in both of the planets are different.
Yeah, that is one of the reasons. Near the top of the atmosphere, ammonia becomes cold enough to crystallize into ice particle cloud. But Saturn is colder than Jupiter, so temperature is the reason. Since Saturn is colder than the Jupiter, these colorful ammonia clouds are deeper in the atmosphere. That's why we cannot see it on the Saturn surface. Now, regarding the Saturn's rings. Saturn's rings were discovered by Galileo in 1600s. The rings tilted the same angle as the equator. We know that there is almost in the previous slide, it talked about the tilt of um, Saturn, an axis tilt of 27 degrees. Even the rings also has the same tilt. It is Hubble tilt same as the equator. The ring's thickness, length, it can be, some 20,000 miles or so, but the thickness is only, sometimes it is 20-meter thickness and up to 1 kilometer thickness can be there. That's why we see it very flat rings. And the components of the rings, mainly it is composed of 93% of water ice and 7% of amorphous carbon. So these rings are differentiated into 7 rings made up of thousands of ringlets and billions of ice particles. And the particles range in size from dust to a car. So, and in between the rings, there are some satellites. So this is a closer picture, schematic picture of the rings of Saturn. How did these rings came into existence? There are two hypotheses. The first one is it might have been remnants of destroyed moon of Saturn. Saturn must have had a moon that was destroyed by some maybe collision effect, and that remnant began to revolve around the Saturn as a um, ring. Or the second one be rings left over from the original nebular material, the solar nebular material that formed the Saturn. That is also one other hypothesis. Now, some of the ices in the rings might have come from Saturn's moon. One of the moon is Enceladus, and it has ice volcano, which means in the previous slide we talked about Cassini-Huygens mission, right? So this is a NASA and ESA collaboration work. And while this Cassini was examining the Saturn, at some point it found that water existence of water in its orbit. So when it was studied, analyzed deeply, it was found that this is coming from or sprayed from one of Saturn's moon, Enceladus. It has some stripes in it, some gaps in it in the southern pole, where it's believed that some maybe some 50 or 60-kilometer thickness crust is there, and inside the crust there is oceanic water. So that might have created some of the ice in the ring system.
Miss, but how does the ice escape the planet?
Because there is gaps within the southern region, and also there are volcanic eruptions from where these volcanoes are erupting ices.
Okay, miss.
Okay, so about the temperature of Saturn, tilt of axis causes seasons on Saturn. Yeah, just like Earth, since it has a tilt, different seasons are being experienced in Saturn, and each season is 7.5 Earth years. While Saturn takes 29 times longer period than Earth to revolve. Top of the clouds, it can be minus 175 degrees, and below the clouds, it's hot. Actually, how can be that? Maybe because of different activities. Gases are continuously colliding together, and these chemical reactions can happen there. So, because of that, below the cloud, it is hot. It gives, if it is receiving one solar radiation, it is giving out 2.5 solar radiation, which means 2.5 times the solar radiation it is giving back to the space. One of the largest moon of Saturn is Titan, which has a diameter of 5,150 kilometers. This Titan is the first.
Which Titan is the second biggest moon in the solar system after Ganymede?
That is right. And Titan has an atmosphere. And there in this Cassini-Huygens missions, there was a lander that is called Huygens, which landed on or impacted on Titan to study more about that planet. Sorry, satellite. And different space explorations have happened in Saturn. For example, Pioneer 11, which was in 1979, then Voyager 1 and 2, Cassini-Huygens in 2004, which is the first spacecraft to land on a moon other than Earth's moon. This is Pioneer 1, Voyager 1 and 2, the Cassini-Huygens. Yes, so that is the Saturn slide. So have a great day, everyone. Tomorrow, I mean. Have a good night today.